And my name is Joakim Tengstrand, and I'm from Sweden. To make it easier to understand Polylith, I would like to begin by explaining the design principles upon which it's built. So there are four important design principles here. Keep things small, move in small steps, separate what from how, and decouple things. So let's start by keeping things small. Here we have a team of 3 people. And a small team is easy to keep in sync because it's small, and because every person in that team has only a few other people to talk to. But if we increase the size of a team to, let's say, 6 people, the number of lines of communication now increases from 3 to 15, which is more than a double. So, and if we increase the size of the team to 10 people, we have 45 connections now. So the number of connections and it kind of increases exponentially here. And also it also gets exponentially harder to keep the team in sync and to, so that's a problem. What can we do? If we have a team of 6, we can solve it by dividing it up into 2 teams of 3 people in each, where a representative in each team is responsible for keeping its team in sync with the other team. So now we have 7 lines here instead of 15, and this is a principle that is applicable to almost everything, actually. For example, it could be departments, it could be companies, and even countries. But here we will think of code when we think of why it's a good idea to keep things small. And the next principle is about moving in small steps. And a good example is the way we work in Clojure or functional languages, where instead of trying to solve a problem with a complicated algorithm, we often just pass data to functions. For example, we can pass data to a sort function, and then maybe a filter function, and then a map function, and then we finish with let's say we take the first element, and that's a way of dividing a larger problem into smaller problems by moving in small controlled steps. And the good thing with this is that we kind of, for every step we finish, we leave complexity and work behind us. So when we come to the last step, this step is as small as the other steps. And if we remember the previous slide, this is good because smaller is better. And another example when we do this is how we can divide our work into smaller portions of work. For example, instead of having a task on our, let's say, Kanban board, a big task, we can divide that task into several smaller ones. And then we can, so every time we move a task to done, we we kind of leave complexity behind us, and each task is easier to finish because it's small. So what is the opposite of this? That is to move in big steps like this. And a good example of this is when we work in long living branches. And the problem with that is that the amount of work we have to work with and coordinate is quite a lot. And also we work with all that extra work, this big load of work over a longer period of time also. So the amount of coordination it's kind of exponentially higher than if we would have divided this work into smaller pieces of work. And another problem here is also that when it's time to merge this branch back, the world has moved on and people have started to push things to this branch. So it will be more work also, boring work to merge our code back. So to summarize, move in small steps as a way of reducing coordination and to reduce complexity. The next principle is to separate the what from the how. And a good example of this is when we use functions, for example, a sort function or maybe a filter function. The nice thing with functions is that the name of the function tells you what it does, for example, filter or sort. And we don't care so much about how it's implemented. We just use it and we understand by the name what it does. Maybe if we get performance problems with the sort function, maybe we have to look into what the problem could be. But the idea is to not care about how it's done. And then another example of this separation is when we have an SQL statement that we can just send to a database engine. For example, select star from person, where name equals Joakim ordered by name. That describes what we want to do or what we want to be done. And then we just sent it to the database engine, and hopefully we don't need to care about how it is performed. And maybe if we get performance problems, we have to add an index or something. But the idea here is that we don't care. And a third example is when we put things on a queue. Here we just say, do this. I want someone to do this work for me. And in some cases, we don't even know who will perform that work. And we don't know when it will be performed. And that is to take it even further. So the idea here is to just care about what we want to do and not how it is achieved. And the next principle is about decoupling. Here we have 3 terrain carriages. And what's good with the carriages? The good thing is that by connecting them, we can create something valuable. In this case, this is a train that can carry people, and which is valuable. And what's good with a carriage is that it can be reused in another train set. So this is an idea that introduces reuse also. And also we can replace a carriage here also. For example, we can replace one of those carriages with a restaurant car. And in that way we have changed the functionality, you could say, of this train. So it gives us both replaceability and changeability. So we could say that this coupling is a good way of coupling things, or when we put things together in this way. And so what is the opposite here? The opposite is when we glue things together, or maybe weld things together. So here we have a huge car where we have kind of welded several cars into one big car here, or carriage. So what's the problem with that? You know, the problem is when we want to replace one part of it. For example, we want this little carriage part that with refreshment here, the restaurant car. Now we need to bring out our welder again and cut it out and replace it and weld it back together again. And this is, of course, a lot more work than to have the pieces decoupled from the beginning. But is there any similar in the software industry where we work this way? Yeah, actually, this is the way we organize code today. For example, this could be a service. So could be a code base that lives in a source directory. And we are often very good at organizing code into namespaces and subnamespaces. So that's a kind of a good thing. But what happens if we want to reuse one part, some functionality in this service in another service? Yeah, then we need to bring out our welder again. And it's not so easy to just cut it out because it's kind of stuck there, because other code around it uses it and it uses other code also. So what is the solution? Yeah, the solution is to have decoupled small blocks of code that each of them live in a separate source directory here. So what's good with this? Yeah, the good thing is that then we can put those code blocks together to give us code bases, for example, a service. And this is what Polylith solves, we could say, what Polylith helps us with. And the green building blocks, they are called components. And when we put them together, we get, so we have projects for each of those code bases, you could say. And we also have a special kind of building block here. It's called a base, and a base exposes a public API. It could be, for example, a REST API. And when we put a bunch of components and a base together, we then get, for example, a REST service here. And we also have a special kind of project called the development project. And this is the project where all our building blocks, the components and bases, live. And what's good with this? The good thing is that it allows us to work with all our code from one place in a single repo. And it also allows us to navigate our code, to refactor our code, and debug our code from one place. So we can, for example, refactor components here that would be really hard to do if they lived in separate projects. But with this way of organizing code, that's easy. So maybe we could summarize the benefits here. So Polylith gives us reuse, because our building blocks, the components and the bases, they can be reused everywhere in all our projects. And the projects is our code bases that we build artifacts from and deploy, like services, or it could be libraries and tools also. So no restrictions there, but it gives us reuse. That's really good. And it also gives us a shared language, because now we have introduced new concepts here, like component and base. And like we said, the base, we know what each building block does. A base exposes a public API, and I haven't talked about the component, but they are where we put our functionality. You can say could be a domain specific building blocks. For example, you could have an invoicer. Let's say you put all the code in the invoicer component, or you could have a logger component, or let's say you have a DynamoDB or a database component, and so on and so on. So when we talk about components and bases and projects here, we immediately understand what kind of building block it is, what the responsibility of that concept is. Yeah. So that helps us when we reason about our code base. It helps us when we design our code, and it helps us when we need to communicate about our solutions and our code. And then it gives us changeability also, because it's very easy to change things here, because those building blocks, they are like Lego bricks. For example, this service here in the middle here, that REST service. So let's say we add a new base here that exposes a lambda function. So what we can do now is that we can replace the existing REST base with this lambda base. And then suddenly we have created a lambda function here. And we haven't changed the components here. So the set of components that was there in the beginning in this REST service, they are the same. We have just replaced the base. So that's an example of replaceability. And also we can switch components and add components and so on. So the changeability is very high here, you can say. And then we have another thing that Polylith is kind of unique in, because it decouples development from production. So what does that mean? Yeah, what it means is that we can make changes in production that doesn't affect our development project or our development environment. For example, we could split up a service into two services if we get, let's say, performance problems, or if we have any other reasons to split it up, without affecting the development project, because that's the development project is just one single code base here. But so how we run and execute the code in production is an implementation detail in Polylith. So in Polylith, we concentrate on how to work with the code in development here, to give that really nice fast feedback loop in a single REPL. And in the beginning, we often just deploy it as one service when the code base is small. But after some time, we maybe realize that, okay, this should maybe run as 2 services or something else. And then it's very simple to just change the way the code is executed, because those building blocks are like Lego bricks, and that also helps with the changeability in how we run the code in production. I talked about fast feedback loop, and the nice thing with Clojure is the REPL. One nice thing with Clojure is the REPL, and here with Polylith, it really not just encourages you, it almost forces you to use one single REPL. And it doesn't force you, actually you can use several REPLs, but you often you will find out that you often work with all your code from a single REPL in Polylith. So it's a very nice fit for Clojure Polylith. And another thing that gives us a fast feedback loop is when we work with the code in development is that we can test our code incrementally. And also not just in development, it helps us with the feedback loop. In our continuous integration and if we use continuous deployment, we also get this incremental way of testing our code, build our code, and deploy our code. Because Polylith understands that if, let's say, we have just changed one component, we only need to test, run the test for that component and the affected projects. And sometimes that is maybe, let's say, 10% of your code base. And that means that it takes just maybe 10% of the time to run the tests. And you not always need to deploy all your, I mean, you only need to deploy your project that has been affected of your changes also. So I think that was everything I wanted to say right now. So now it's time for questions. Yeah, so this is the Polylith tool, or the Poly tool, that helps, that you can use to work with a Polylith workspace, as we call it, this monorepo. And the Poly tool itself is Polylith workspace. So if we run the info command here, okay, we should maybe not start. Okay, sorry. Okay, instead I wait with that a little bit. So this is the workspace. This is an example of a Polylith workspace. And it's structured like this. We have a number of bases here and components. And the components are the most important parts here. So we can open up something. This is something that people understand. This is I have a component that takes care of file operations. So here is the interface that I talked about. So it's an interface. So a namespace with the name interface here. So the structure here is that each component has a source and a test and maybe a resources directory. So all components live in separate directories here under the components directory here. And if you take some bigger, this is a bigger component, one of the biggest. So here And this is how it can look like. So here we have an interface here. So this component only exposes one function, workspace from disk. And then it kind of delegates its internal work here. So it delegates to this core namespace here. Oh, sorry. This is the core. And then it uses, and it have a number of internal namespaces here within this component. And then it also uses other interfaces actually, or components via their interfaces here. So this component, the workspace CLJ, uses file and the git component and the util and blah blah and some other components here. And so this is how it looks like. And then and then we have the projects folder here. And here is the poly tool. I typed, if I say poly, poly version, let's say. And it's so the poly tool here has no source folder, but it's a project. So what is it? And this is a tools depths project where we just list the components and the base that this project uses, and also some libraries here, but it will also include the libraries that are specified here in each. For example, here this component has a library. So that means that we just need to specify the components, or the bricks as we call it, components and bases, and some libraries. And then we have a project. And if we look at the info command here, we can see that this is the whole workspace for the Polylith the monorepo. And the column here is the poly project here. And each column says, the first column says if it includes a source folder, the next if it includes a test folder, and then if the tests will be executed if we run the test command. That's the third column here. So this gives you a really nice overview of your code base, your Polylith code base. And as you can see here, a lot of those components are reused in other projects here. And this is, for example, the migration tool. It has only 1, 2, 3, 4, 5, 6, 7. It uses 7 components. One of them is the migrator. That's the only project that uses the migrator component, the migration, the polymigrator project here. So we can, for example, polydeps. We can type migrator, and it will tell us what dependencies it has. It says that this migrator is used by the base migrator CLI, and it uses those 3 interfaces actually. So the components owner knows about interfaces, and the interfaces the interfaces are those here, those namespaces here called interface here. Here. So each component has a namespace called interface, where you put everything you want to expose. And this could be def statements, as here. Most of them are def def-end statements, but for example, you can even put def macros here also, so you can expose whatever you want here in the interface. And the good thing with that is that because components only knows about the interface, and that enables us to swap the implementation of components without the surrounding code noticing it. Is because the code only knows about those interfaces, they don't know about concrete components. I don't know if that was clear. And we can, for example, if you run the libs command here, you can get an overview of what libraries are used in each project here and by the components here. And we have the deps command. This shows the dependencies, but the thing with Polylith is that we don't need to care much about dependencies, because it kind of we just put those components together that we need into projects, and then it kind of just solves by itself. So we don't need to use dependency injection or things like that. You just because tools.deps is so modular, you just need to specify the source directories of those components, or actually not even that. You just need to specify the set of components and bases to use in each project, and then you have a new service or whatever, a tool. For example, the poly here is a tool; it's not a service, but it still benefits a lot by using Polylith.
Right. Can you share one more time? Can you show one more time how do you define the dependencies?
Okay. Yeah. Okay. You mean in the project?
Yeah, that's correct.
Yeah. So this is just an ordinary two steps project.
Okay, great. So is there any special annotation, something that tells Poly whether the dependency is a Poly component or just an external library?
Yeah, no, it's just that we need to specify the top namespace here. Polylith CLJ core is the top namespace here. So all the components and bases here, they live in this Polylith CLJ core here, Polylith CLJ core. And then the next namespace here is the name of the interface. And the interface here in this code base, the name of the interface is always the same as the name of the brick, the component or base, or a component. It's only the components that have interfaces. But if we, for some reasons, want to have more than one implementation of an interface, we can have that. So we could create let's say, I don't know, let's say migrator, some kind of advanced migrator here. We could do that. So then that component would have another name than migrator, but the interface would still be migrator. So if and in that case, we would have another director here under components called migrator advanced or something. But in here, it would still live in the same namespace, core migrator here. So that's what the interface is. That's the the namespace, you can say here, for that where the component lives. That's the interface.
Yeah, and each component define the external dependencies in the depCDN inside the component.
It doesn't normally. It doesn't. I mean, it only specifies the libraries it uses. It doesn't know. So the tools depth definition doesn't know about other components or interfaces here.
Yeah, no, external library.
Only external libraries, as we, in this case, for example, here, we specify a library here.
Okay, great. Thank you.
And if you run the, no, not deps, libs. I was going to. So we can check here if deps is using this two steps up. So here we, the deps brick here is using two steps alpha here. And this is the version here. Yeah.
And if more components are using the same library, it uses just the standard conflict resolution.
Yeah, it will take the latest. But you can also override deps here for a specific project if you want. Otherwise, it will take the latest version specified by any component, or if it's specified by the project also. So you can kind of override what version of each library you use. We could maybe, let's say we can maybe do that here. Let's say the deployer uses, I don't know, maybe we have a version like that. If we run this again, let's see if it works. And that was the sound.
Yeah, now you get the two different versions.
Yeah, but this version is only used here by the deployer, but not used in any project. Is that easy to understand? Yeah, so we can also go to the project here. And let's say we use, I don't know if there is, now nothing will happen because that's an older version, but maybe if we, maybe that, I don't know if we have that version. It's good. Yeah, now the Poly project uses this version because we specified it here. Yeah, and it's hard to explain how it is to work with, but it's really helpful to be able to work with the code in a single code base like this, because here we just import, for example, here we import the Git component here, and it's used in the code git / here. That's how we call a function from this, and then we can easily navigate here to this. So it will navigate to polyinfo. It will navigate to the component that is specified here in the development project. So, but we have only one version of each interface here. So it will always navigate to the concrete component, the code for that automatically. Because the components in the development project is specified here. And because I use cursive, and cursive doesn't support 100% this way of specifying the components. So I need to specify them as paths, extra paths here. But if you use, for example, Emacs Cider or Visual Studio Code and Calva, then this works. So you can specify each component with one in the same way in the development project as the other projects. The only difference here is that you always need to specify the test folders also, the test directories, because tools.deps doesn't inherit the test directories by default from if you include them as a local root dependency, because those are treated as dependencies. So it's kind of, but this is the way Polylith supports dividing up a code base this way by in using tools.deps by using local root